What force can transform the meticulous promise of human ingenuity into a primal, destructive roar in a mere heartbeat? On May 28, from the quiet aspiration of a launch pad, a brutal testament erupted. What began as a static fire test for Blue Origin's New Glenn transformed into an inferno. A massive fireball engulfed the vehicle within a mere 5 seconds of engine ignition. Over 1,000 tons of liquid methane and oxygen ignited. The spectacle, visible from tens of miles, was not of triumph, but of catastrophic destruction. This immense energy, unleashed in an instant, leaves a profound question lingering over the very ground it scorched. How could a moment of testing escalate so violently, so fast? The epicenter of this devastation was the BE-4 engine area. Here, the first stage suffered a catastrophic failure. Critical launch infrastructure at Launch Complex 36 was obliterated. A lightning tower, once a sentinel against storms, and the transporter Erector, engineered for precision, were utterly destroyed. The main launch tower itself sustained structural damage. The scale is profound. This event stands comparable to the largest Starship explosions. It is potentially the largest launch pad explosion ever recorded at Cape Canaveral. The sheer physical footprint of this incident speaks to a raw power rarely seen. This singular, violent event reverberates far beyond the scorched Earth. It casts a long, immediate shadow over Blue Origin's lunar ambitions. The Blue Moon Mark 1 lunar cargo mission, initially slated for late 2026, now faces critical delays. Damage to Launch Complex 36 alone requires at least an estimated 15 months for repairs. This pushes Blue Origin's lunar operations deep into 2027. This delay directly impacts NASA's Artemis schedule, and places a stark question mark over the readiness of the entire Blue Moon lander program, including the crucial Mark II crewed lander for Artemis 3. A single catastrophic moment, reaching years into the future. The quest for alternative launch solutions now reveals the stark realities of the heavy lift market. ULA's Vulcan, a potential substitute, offers a mere 6 metric ton lunar payload capacity. This is significantly insufficient for the approximately 21 metric ton Blue Moon Mark 1. SpaceX's Falcon Heavy, in its expendable configuration, could theoretically deliver close to the required mass. Yet, it critically lacks liquid hydrogen refueling infrastructure at its launch sites. It also presents formidable structural integration challenges due to divergent payload processing philosophies. This situation inevitably increases NASA's dependence on SpaceX's Starship for its lunar future. That dependency deepens further with the sudden vacuum in medium and heavy lift capacity. In this void, another future is already being forged. SpaceX is developing Starfall, a reusable orbital vehicle aimed at microgravity manufacturing and rapid global cargo delivery. It could potentially succeed ISS functions and scale mass production for cost-effective orbital returns. Blue Origin CEO Dave Limp has targeted a New Glenn return to flight before the end of 2026. This is an ambitious goal. History offers a sobering contrast. SpaceX's Amos 6 explosion repair for SLC-40 took over a year, while repairs to Launch Complex 36 are actively underway, leveraging existing designs, experienced contractors, and new towers, ground support equipment, tanks, and piping already in production. The race against time is existential. The fiery birth of the universe is mirrored in the destructive power unleashed on that fateful day. Blue Origin's struggle to rebuild is a poignant reminder of the fragility of even the grandest ventures into the unknown. We are left with a cosmic whisper. The path to the stars is paved not only with ambition, but with the ruins of unforeseen challenges.